An ungrounded well pump presents serious electrical hazards. The grounding conductor provides a safe path for current to flow in the event of a fault, preventing it from traveling through water or other conductive materials. Consider a scenario where a person or animal comes into contact with the pump while it's in a faulty state. Without a grounding conductor, the current could pass through the person or animal, causing severe injury or even death. A temporary grounding solution can be implemented while arrangements are made for excavation. This involves a grounding rod and clamp. Drive a grounding rod into the ground near the well and connect it to the grounding conductor of the pump using a grounding clamp. Verify that the grounding path from the pump to the grounding rod is continuous and has low resistance. Use a multimeter to measure the resistance between the pump's grounding terminal and the grounding rod. It should be less than 1 ohm. This solution should only be used as a temporary measure until proper grounding can be restored. It's essential to ensure that the grounding path is safe and effective before operating the pump. Emphasize that ungrounding the well pump is a serious safety hazard that must be addressed immediately. The actions of cutting the grounding conductor are irresponsible and potentially dangerous. Advise contacting a licensed electrician to resolve the grounding issue as soon as possible. To elaborate further, the purpose of a grounding system is multifaceted. Firstly, it provides a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices like circuit breakers or fuses. Without a proper ground, a fault current might not be high enough to trip the breaker, leading to a prolonged hazardous condition. Secondly, the grounding system helps to maintain a stable voltage potential, reducing the risk of electrical shock. In the absence of a ground, the exposed metallic parts of the pump could become energized, posing a shock hazard to anyone who comes into contact with them. Thirdly, grounding protects equipment from damage due to voltage surges, such as those caused by lightning strikes or utility switching operations. A properly grounded system can safely dissipate these surges, preventing damage to the pump and other electrical equipment. The temporary solution involving a grounding rod is intended to provide a limited level of protection until a permanent solution can be implemented. The effectiveness of this temporary ground depends on several factors, including the soil conditions, the depth of the rod, and the quality of the connections. It's crucial to select a grounding rod that is appropriate for the soil conditions. In areas with dry or rocky soil, a longer rod may be necessary to achieve adequate grounding. The rod should be driven deep enough into the ground to reach moist soil, typically at least 8 feet. The connection between the grounding conductor and the rod should be made using a grounding clamp that is listed for the purpose. The clamp should be securely tightened to ensure a low resistance connection. When testing the grounding resistance with a multimeter, it's important to use a meter that is designed for this purpose. A standard multimeter may not be accurate enough to measure low resistance values. The meter should be connected between the pump's grounding terminal and the grounding rod. The resistance should be measured with the pump disconnected from the power supply. A reading of less than 1 ohm indicates a good grounding connection. If the resistance is higher than 1 ohm, the connection should be checked and the rod may need to be driven deeper into the ground. It's also important to be aware of the limitations of a temporary grounding solution. It may not provide the same level of protection as a properly installed permanent grounding system. It's essential to exercise caution when working with electrical equipment and to avoid contact with the pump while it's in operation. Furthermore, the National Electrical Code, (NEC), provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property. It's important to consult the NEC and to follow its requirements when installing or modifying electrical systems. Some specific NEC sections that are relevant to grounding include Article 250, which covers grounding and bonding, and Article 430, which covers motors and motor circuits. For example, NEC Section 250.50 covers grounding electrode systems, which specifies the types of grounding electrodes that are permitted and how they must be installed. NEC Section 250.52 covers grounding electrodes, which provides specific requirements for different types of grounding electrodes, such as ground rods, ground plates, and metal underground water pipes. NEC Section 250.166 covers sizing the grounding electrode conductor for alternating current systems. These tables provide guidance on the proper size of the grounding electrode conductor based on the size of the service entrance conductors. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It's important to check with the local authorities to ensure that all electrical work is performed in accordance with these codes and regulations. A licensed electrician will be familiar with the NEC and local codes and regulations and will be able to ensure that the grounding system is properly installed and meets all applicable requirements. When selecting an electrician, it's important to choose one who is experienced in working with well pumps and grounding systems. The electrician should be able to assess the existing grounding system and recommend the appropriate repairs or modifications. The electrician should also be able to provide documentation of the work performed, including a description of the repairs or modifications, the materials used, and the test results. This documentation can be helpful for future reference and for insurance purposes. Finally, it's important to remember that electrical work can be dangerous. It's essential to take precautions to protect yourself from electrical shock. Always disconnect the power supply before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you're not comfortable working with electrical equipment, it's best to hire a licensed electrician to do the work. The well pump operates at 220 volts. This voltage level is considered hazardous and can cause serious injury or death. It's essential to exercise caution when working with electrical equipment that operates at this voltage. The plumber's actions of cutting the grounding conductor were not only irresponsible but also a violation of electrical codes. Grounding conductors are designed to provide a safe path for fault current to flow, and cutting them eliminates this protection. The plumber's actions could have created a dangerous situation for the homeowner and anyone else who came into contact with the well pump. The homeowner should be advised to report the plumber's actions to the local authorities. The authorities may take disciplinary action against the plumber. It's also important to note that the grounding conductor should never be used as a current carrying conductor. Grounding conductors are designed to carry fault current only, and using them to carry normal operating current can overload them and create a fire hazard. The well pump is typically connected to a dedicated circuit breaker in the electrical panel. The circuit breaker is designed to protect the circuit from overcurrents and short circuits. If the well pump experiences a fault, the circuit breaker should trip, disconnecting the power supply. However, if the grounding system is not properly installed, the circuit breaker may not trip, even if there is a fault. This could lead to a prolonged hazardous condition. The size of the circuit breaker for the well pump should be determined by the motor's full load amperage rating. The full load amperage rating is typically listed on the motor's nameplate. The circuit breaker should be sized at 125% of the motor's full load amperage rating. For example, if the motor's full load amperage rating is 10 amps, the circuit breaker should be sized at 12.5 amps. In this case, a 15 amp circuit breaker would be used. The wiring for the well pump should also be sized appropriately for the motor's full load amperage rating. The wiring should be sized according to the National Electrical Code or NEC. NEC Table 310.15. B16 provides guidance on the proper size of conductors based on their ampacity. The ampacity of a conductor is the maximum amount of current that it can safely carry. The wiring for the well pump should have an ampacity that is at least equal to 125% of the motor's full load amperage rating. For example, if the motor's full load amperage rating is 10 amps, the wiring should have an ampacity of at least 12.5 amps. In this case, number 14 American wire gauge or AWG copper wire would be sufficient. However, it's important to consider the voltage drop when sizing the wiring for the well pump. Voltage drop is the decrease in voltage that occurs along the length of a conductor. Excessive voltage drop can cause the motor to run inefficiently and can even damage it. The NEC recommends limiting the voltage drop to 3% for branch circuits and 5% for feeders. To calculate the voltage drop, you need to know the length of the wiring run, the current flowing through the wiring, and the resistance of the wiring. The resistance of the wiring can be found in NEC Chapter 9 Table 8. If the voltage drop is excessive, you may need to increase the size of the wiring. The well pump is typically controlled by a pressure switch. The pressure switch is designed to turn the pump on and off based on the water pressure in the well. The pressure switch is typically located near the pressure tank. The pressure switch has two set points, an on pressure and an off pressure. When the water pressure drops below the on pressure, the pressure switch turns the pump on. When the water pressure reaches the off pressure, the pressure switch turns the pump off. The pressure switch should be adjusted so that the pump cycles properly. If the pressure switch is not adjusted properly, the pump may run continuously or may not turn on at all. The pressure tank is designed to store water under pressure. The pressure tank helps to maintain a constant water pressure in the house and reduces the number of times the pump has to cycle on and off. The pressure tank should be sized appropriately for the size of the house and the number of people living in the house. A general rule of thumb is to provide 8 to 10 gallons of tank capacity per person. The pressure tank should be pre-charged with air to a pressure that is slightly below the on pressure of the pressure switch. For example, if the on pressure of the pressure switch is 40 pounds per square inch or psi, the pressure tank should be pre-charged to 38 psi. The pressure in the pressure tank should be checked periodically and adjusted as needed. A well pump can be submerged in the well or located above ground. Submersible pumps are more efficient and reliable than above ground pumps. Submersible pumps are also less likely to freeze in cold weather. However, submersible pumps are more difficult to service than above ground pumps. Above ground pumps are typically used for shallow wells. Above ground pumps are easier to service than submersible pumps. However, above ground pumps are less efficient and reliable than submersible pumps. Above ground pumps are also more likely to freeze in cold weather. The type of well pump that is used depends on the depth of the well and the amount of water that is needed. In summary, the grounding of a well pump is a critical safety measure that should never be compromised. A proper grounding system protects against electrical shock, prevents damage to equipment, and facilitates the rapid operation of overcurrent protective devices. A temporary grounding solution can provide a limited level of protection until a permanent solution can be implemented. However, it's essential to consult with a licensed electrician to ensure that the grounding system is properly installed and meets all applicable requirements. The electrician can assess the existing grounding system, recommend the appropriate repairs or modifications, and provide documentation of the work performed.